I write a compiler for an Oberon-like programming language, but a bit simpler. The compiler is already self-hosted and written in itself, but it is not finished yet, so some features are missing and implemented one by one, and I can use them, of course, when they are already implemented. And the one thing that was missing for a long time is error checking, and I started work on the error checking in the recent time, and I'm currently go through my parser, and so the compiler assumed that the code that it compiles is correct, so it didn't do any error checking, and now I just check whether the parse code is correct and report an error if not. And I was working on this enumeration type expression. This is the thing that I finished. So basically, if we define a type, so I currently error check this type section, and for example, this is an enumeration. So there is an identifier equals, and then we have values in this enumeration, and the same is for records. So we have identifier, the type name, and then the type definition. And I finished this enumeration type expressions, and this one parses the type expressions that I showed before, and the next one is actually the record type. And this is this function. So the first step is that we skip the record keyword. Then we allocate them memory for the record type expression. We initialize the allocated memory, so it does not have any members at first, and the length of the array of the record fields is 0. And the next thing that we read is actually the field name, I think. And then we read the semicolon. So we replace this lexer function with the parser function expect. I will split the screen and we'll look up in the code that I've already done before. Here in the bottom half, enumeration type expression, this is this one, and we have here this expect function. Parse expect gets the cursor. The cursor is just the current position in the stream of tokens. We expect an identifier here. I actually not allowed to do it like this. The token, no, so lexorit is okay. Then we need to check whether the token is the end token, so records can be empty. And if it is the end token, then we finish the parsing and go to the end of the function. But if it is not, then we report, then it should be an identifier. That actually means that if token kind is not an Alexa kind identifier, then we create an error. This seems to be wrong. Then we create an error. We need to define this variable parser error. And we say that we expect two possible tokens at this position. This can be the end token, and it can be an identifier. And then we add this thing to the error list. So here I will try to compile the code, and this one is actually doesn't look correct. So an error unexpected token create. Oh, it sets the token. I thought that some variables like the current token is missing, but it takes the current token from the cursor, so it is fine as it is. And the compiler can compile itself and passes the final tests. So we can continue now. And here we have an error, so we can actually just jump to the end. To the end of the function and return. After that, we allocate memory for a field, increase the field count, set the field name and name length, and then we expect a semicolon. Of course, not a semicolon, but just a colon, as the comment says. And in this case, we can actually check. In this case, we can just call this function, no, not this function, but parser expect, I think. Exactly, the first argument is the cursor. Then we have an Alexa kind column, I think, and the last one is the error list. If this function returns a nil, then we have an error, and we can jump to the end of the function and exit this function. So let us compile it once again. After that, we add the new field to the list of the fields in the record, and then we read the next token. Is if the next token is a semicolon, then we expect an identifier as the next token. So actually here we can say that the parser type expression, actually I don't know, the question is whether I want to have, so semicolons are not trailing semicolons. Semicolons separate the fields, but I allow, and the same is for statements, so semicolons separate statements, but they are not trailing semicolons as in the most programming languages, but I actually allow currently trailing semicolons just to make the grammar a bit more flexible, and I can actually do the same for the records, but in this case it is not an identifier in any way. So actually if we have a semicolon, then we skip it. No, we already skipped it here, and we reach the identifier after the semicolon, and we jump to this label. So I use labels and go-tos. These are actually loops, but I have not implemented a while loop yet. So I use jumps for looping, and exactly so after I've already read the thing. I can actually jump to this statement, or probably to here. Let us move the label, and we won't read the token here, but just jump to the beginning. This actually should work. And I think that I actually can jump unconditionally. So I skip the semicolon and then read the next token, and it can be end or not. And in this case too, this can also be end. So I just check whether the token kind is end. And if this is the case, then we can just leave the function. This result kind assignment can be moved to the beginning, where we initialize the first fields, and here actually we do not do anything if it is end, so we just go to the end of the function. But if it is not the end of the record declaration, then we have a problem here, and our problem is actually so we do the same. We allocate an error and add it to the error list, and the expected symbols in this case are semicolon or the end token. So, and that is actually it. The one problem, this thing can actually return an error, and if it returns an error, we can actually skip the rest of the record, or we can try to continue to parse it. Do I have any function to check whether the list is empty? Probably not. So I have initialize function, append, prepend, insert. If the first and the last, or the last element is empty, then this is empty. Do I check this somewhere? Yeah, for example, here I check whether the error list is empty. Otherwise, I do not try to compile, to call the next comment stages of the passes of the compiler. Yeah. So I would say, let us write a function that checks whether the list is empty. So well, it looks fine. Now we can go back to the record parsing, and as I said, if I do not know whether I have a not function. I do not use the not operator. Not sure if it will work properly. Or I can actually, there is of course an easy way. There is an easy workaround. I can just explicitly check for false or true. because I have the language itself has a not operator, but this operator has two meanings depending on the type of the operands. In one case this is bitwise negation, and in the other case it is the negation of a boolean, but I do not have a proper type checker, so I'm not sure whether this operator is working properly at the current stage. I do not use it anywhere. Therefore we are going to just check if elna list empty for the error list, whether this thing is true, and if it is then it is the case, then we skip and we do the final test, and then we can continue with the next function. Okay, I'll just revert to this change. So we have enumeration, we have records. The next one is the pointer type expression. And first we read the head symbol, so for the pointer, and then we just parse the nested type in the pointer, and then we return the result. So there is not a lot of things that can be done. And the next one is an array. An array could be a bit more complicated, and I already have the error checking here, so if it is not some designator of a type declaration, then we return an error here. So let us look into the array type expression. And we read the left square bracket, and after that we actually, so I know because I entered this function that the current token is left bracket, but at the end we expect that the current token is the right bracket. I'm not sure whether it is how it is called. So what do I have? Right square. So then it is right square, and we need to pass an error list. And since the function call already contains the token that we expect, we actually do not need this comment anymore, so we can just remove it. Then we parse the nested type, and here we parse actually the binary expression. So binary expression is just a generic expression. Actually, it is the array index. It can be a constant expression, so an expression that can be computed at compile time. But currently I do support only integers. And if elna list empty error list is false, then no, if the error list is true, then we continue parsing this thing. Otherwise we just return the value. And this function is then finished as well. And all tests pass. So then we continue with the next function. So type expressions are finished. Let us see where this function is called then. This is parser procedure declaration. This is probably variable declaration. We will look at it later. These are nested type expressions. Parser type declaration. So exactly, I actually do not free it. So I return nil as result, but I actually can also return a partly parse type, or I can free them. It really doesn't matter, I do not do it yet, so let us skip it for now. Probably we will implement something like this later. So actually if we fail, then we just return. This is fine. Let us compile it here. Or I can clear the screen only after this thing is finished. So I do Ctrl L, but it will clear the screen at the end. Interesting. Didn't know that. So then we'll look at elna parser type declaration. And it is called here. Here we check whether the parser node is nil or not. This check should be then replaced because we do not return. I should really return just nil, then I can easily check whether it failed or not. Let us define a help function. So free actually does not return. Probably if we return something. I do not have man pages here probably. Okay. Let us define a function free and nil. We can pass a pointer to this function, but it won't be able to set the pointer to nil actually, because I need to pass the pointer to pointer then. So we do it a bit more easy. We do free and nil, and this function will get some pointer of type pointer. So pointer is a generic pointer type, something like void pointer in C, and it will return a pointer. And it will free the pointer and return nil. And we have an error somewhere. We do not need the semicolons here anymore. And I have free result here, and instead of free result I will call free and nil, and we'll just assign it to the result. And let us visit these places where we called this empty function. Empty, exactly this empty function, for example here, because elna parser type expression probably returns a nil. So here, if I see an error, then the result is already nil, so it should already work. But this function should return. Let us find it here. So we'll look once again for this empty function. Parser type expression. Exactly. Name type expression is just an identifier, so it cannot produce errors during the parsing. Then we have this parser enumeration type, and oh, actually I can even add errors here. And here I have already a loop label, so I need to check whether we have errors here anyway. This is the first case. Then we report an error here, so we have to do here the same. So we check it here. Expectation peak. So here we expect an identifier for the enumeration, and here we expect a comma or right paren. And these are actually only the cases. Okay, that is fine. We want to test it. and then we go to the elnode parser record type expression. This one reports an error here and goes to the end, so we can set result here. Then I do not need this check here, I can just check for nil. And that is actually it, I think. Then we have parser pointer type expression. Base can be nil here, so if result base is nil, then result is nil as well. And the last one is integer array type expression, and here we have the same, so we can check length. elnode3 array type expression, elnode3 array type expression, length is a word. This is actually not a word. We can do I have a type for generic expression? Literals 3 not 3 type expression, 3 expression, this one. So the proper type is elnode3 expression. Exactly the same as the index during the array access. So elnode3 array type expression. Then we have it here. We allocate memory for it, and if result length is nil, then we have an error and we expect another thing, and if this thing fails, if result length is nil, then the result is free and nil result, and here actually the same. So if this thing is nil, then we do the same. We expect the right bracket, and we free the result if there is an error, and this thing can fail as well. So we do another check here. If base is nil, then return nil. Actually, here we want to do else statement. Well, let us revert some changes and see where it has gone wrong. Okay, this compiles. Then we replaced this one with an nil check. This actually should be fine as well. I do not think that this thing can return nil. Okay, here is an error somewhere. Okay. If this function returns nil, then we reset the result. It compiles now, and then we assign base and check base for a nil value. And so this fails as well because I always forget then and semicolons. This is exactly the reason why I implement the error checking now, because working without the error checking is kind of tedious, and compilation takes some time now because the compiler doesn't optimize the generated code yet. So error checking is kind of important so that I do not need to recompile everything every two lines. So I hope that the working on the compiler will be a bit more easy with the error checking in place. And this can be actually replaced with an else statement, and then we can end it here. Yeah, I think that's fine. So we do the final test here. Okay, then this function is done. And we can now go to the type declaration. I think, do I free the result here? No, but the result won't be set if there is an error. Okay, that's fine. Then we go to the parser type declaration, and this is already done, so that I set the result here to nil. And let us see, and it is called in this type part. The declarations themselves are not separated by anything. So actually I just parse a type declaration. It will not work. The current problem is that I expect that a parser type declaration returns a nil to see where the type declarations end. The thing is that when I go into this loop, so here I skip the type in the beginning of the type section. After that, I need to pick the next token in the stream, and I need to check whether this token is an identifier. If this token kind is an Alexa kind identifier, then we have a type declaration, probably. So then we try to parse this thing. If the parser node is nil, then we have an error. But this error is actually already reported, so everything that I need is just to skip this block. So I go into this block only if the parser node is not nil. This is actually fine. And then I jump to the beginning of the loop. This actually should be fine, and if it is not an identifier, then the next section should be able to see if this is probably next section or not. So let us try to compile it once again. Now let us move to the next section. This is the variable section. Variable part, I think I do not have const part yet, only variable part, or okay, and it is called from here. Actually, we should return nil if there is an error, so I have to check. If result types is nil, I think that even if we do not have any types defined, this procedure should return something. So the result is an LNet declaration. Or if it does not have any types, it will still return nil. So we can see whether it's an error or whether there are no types in the module. We have to check whether error list is empty or not. This is actually also possible. Okay. So when we enter this function, then I haven't read the var keyword yet. So here we have to pick the first keyword and check whether it is var. If it is not var, then we jump to the enter the procedure and just return nil. If it is, then we read the next token, and the next token should be actually an identifier. It is actually very similar to the type declarations, so let us look at the type declarations. and here we read the token. And if this token is not an identifier, then we jump to the end of the function, because probably this is the next section in the module. So we check once again whether the kind is an identifier. Oh, this is wrong. We skip the var token here, as the comment says, but we go into this loop. And this is actually the place where we expect an identifier. So we move it. Here we begin a loop. We skip empty lines. Skip empty lines basically means skipping comments. This is the old function name. So if it is not identifier, then I jump to the end, and I already have this check here. And then if it is an identifier, then I pass a variable declaration. So then we go in here. Here I pick the first token. I set the result to nil. I actually already know that, no, I only know in the case of the first identifier that it is an identifier. So here I check whether it is an identifier, then I jump back, meaning if I call this function, I already know that the current token is an identifier. And here I should skip the colon. We can remove the comment because now we see in the code that we expect a colon, and only if it is a colon we continue the parsing. So then we parse the type, and we allocate the declaration only if the returned type is not nil. Otherwise we return nil at the end, and here we just assign the values to the declaration, and that's it actually. Why is type declaration is implemented differently? So parser type declaration, and here I check for the identifier, but it would mean, yeah, we do not need it here. I actually do here the same. I only enter this loop if I already know that the first token is an identifier. That means that I do not need this check here. I can just keep the token right away and then remove this stuff here. So here we will have the same. If we actually need to condition whether the result is nil, and if result is nil, then the list will be not empty anyway. So I want to enter this condition here, and I want to check whether the list is not empty now. Only in this case I want to parse the remaining parts. But I have to free the result actually, so just do the same. The result, and exactly, so I parse the next part, and if result is not empty, then I free the result. It should be actually okay to pass a null point to the free function, and only if the result is still not nil, then we can parse the remaining module sections. And now we can move to procedures, or I can finish this part actually, so we do not return to this stuff later. I just check again for any errors in the list. Exactly, and basically if the list is not empty, then I still want to free it. We have procedure declaration and we have procedures function. And that parses a list of procedures. So Is this actually, this is type declaration, parser, var, variable declaration. Have here this expect, okay. Exactly, so we skip the comments again, then we pick the next token in the list, and we check whether this token is prots. If it is the case, then we parse the procedure. Here we can check whether the result is nil. The variable, the parser node shouldn't be nil as well. Yeah, exactly. This is this case here, basically. If parser node is not nil, then we do this thing here. And now we can slowly move to the parser procedure declaration. We already know that the first token is prots. Then we expect so it returns the token that it skips. And we can just replace this function with elna parser expect, and we expect an identifier here. Only if it is really an identifier. I should really just define a label here, because the function is just too long for nesting ifs. So we are going to define a label here, and we will jump to this label. is the same. So is this left parent? Yeah, left parent error list. If this function returns nil, then we have an error and we go to the label at the end. So left parent, then we begin with the parameters. We pick the first token. If it is not the right parent, then it should be an identifier. And here we expect they will expect the right pattern, I think, because we still have to skip it after picking. Okay, then the parts the variable declaration, and in this case we do not know whether it is an identifier, and I think that okay, here I check. Well, exactly. In this case, I do not know whether it is an identifier, but I expect an identifier here. So actually I have to check it too. Do I need this token? Yes, I need this token. So we can actually replace it with the expectation function as well, because we expect the variable name here, and we check for an identifier and pass the error list to it, and then only if this everything is not nil, then we can continue. If next declaration is nil, then we can leave the function. And here we check for a comma. If it is a comma, then I skip this token and go to the parsing of the next parameter. If it is not a comma, then it should be a parent. So actually here we can just say that we expect a right parent and this should be fine then. So this section is done. Why I do need this parameter head anyway? I can just use result parameters for it. Then I do not need this assignment. So we pick the next token and check whether it is an arrow. If it is an arrow, then we parse the return type. Here's the result nil. So we skip the arrow and we parse the type expression. If result return type is nil here, then we have an error. So let us check it. Okay, then we begin with a procedure with local variables of the procedure called temporaries. We parse the variable part. Exactly, it checks for the var thing, and if list empty error list is false, then we free and nil the result and jump to the end. Otherwise we continue here. Okay, parameter head is used once again at the end, but it is used independently, so we can assign it right away to the record member and remove this assignment. There is no semicolon here, I think, and we do not skip any new lines. This was my old parser. So then we pick the next token and check whether it is begin or whether it is a return statement. If it is begin, then we skip it. If it is return statement, then we parse a return statement and assign it to the parameter head. And parameter head is basically the statement list. So we can just use result body here and remove this assignment and remove the local variable. If it is not a begin, or if it is not the return statement, the return keyword, then we expect the end keyword, and if it is not the case, then we free the result. And that's actually it. The comment does not say anything. Okay, we added parsing functions and error checking to the top module things, to type declarations, global variable declarations, and procedure declarations. The only thing that actually remains is error checking in the parser of function bodies, so expression statements and stuff like this. And I think that I will continue here next time.